and give you a few examples of how it's used in circuit analysis. So to begin, Ohm's law is basically a comment about resistors, or a property of resistors, something like that. You'll remember, hopefully, that the symbol we use in a schematic for a resistor looks like this. At least if you're American. I understand that if you're European, it looks like a box, which I respect, but somehow doesn't seem nearly as exciting as this kind of squiggly line. Resistance, which is a property of resistors, is typically denoted, or often denoted, as R. It's measured in units of ohms, which are named after a famous German engineer who investigated the properties of resistors. And Ohm's law is given in a couple different forms. One looks like this: V is equal to I times R. So what this means, if I have a resistor and it's got some voltage across it, V, and it has some current through it, I, then the relationship between the voltage and the current is that the voltage is I times the resistance. We can manipulate this algebraically to also say that I is equal to V over R. So if I were to give you voltage and resistance, you could compute current. And sometimes, we don't do this that often, but sometimes our goal is to determine what a resistance is. And so if we can measure voltage and current, we can say that the resistance is the voltage over the current. So those are all examples of Ohm's law. And what I'd like to do now is a few examples that show you how to apply Ohm's law. And then we'll finish up by talking about how to compute power dissipation in a resistor. In fact, that's a point I should make now and we'll make again. Real-world resistors always dissipate power. Most of the time, a resistor is modeling some circuit element that turns electrical power into heat. We model light bulbs as, at least incandescent light bulbs, as resistors. And there, some of the energy actually gets turned into light, but typically resistors convert power into heat, or electrical power into heat. So to do an example, let's